Okay, so today we're looking at function notation. It's just looking different, but it's not different than anything you've done before. So we have an equation, just like we've seen, nothing new, y equals 3x plus 4. So instead of y, we just simply change it to f at x. That's all we're learning today. Everything else you've done already. Okay? But if you change its appearance, you guys start freaking out. That's just function notation. Okay? So we can also say h at x. If we're measuring height, we'd probably use an h. If we're doing temperature, we'd probably use a... Good. What if we're doing altitude? We'd probably use a. Okay? But what's the generic one that we always go back to? F at x. Okay? So that's the common go-to one. Okay, so don't be too concerned about that. F at x. Now, what is the x? All we're doing is we're putting the brackets tell us what the variable is. So if we're measuring maybe, I don't know, if we're measuring maybe the height, maybe we call it f at h. Or if we're measuring maybe the altitude, we call it f at a. We put a in brackets. So it's just telling us what letter we're going to see in the equation. So if you look at the example in the box, there's an x in the bracket, and that's because there's an x in the equation. They must be the same. Okay. We use the word of, so f of x, or f at x. So of or at, it's the exact same, no big deal. Okay. So we have a common question, which you've seen before, y equals 3x plus 4. Then we're saying find y when x is 7. What would we do? Put 7 in, and we say y equals 3 times 7 plus 4, y equals 21 plus 4, y equals 25. Easy, easy. And that's all we're going to do a lot of this today, is we're going to substitute in and simplify. So we're going to take this, is a fancy way of saying x equals 7. That's all it's doing. Right? In brackets, there's a 7, so you take the 7 in the brackets and you put it in for x. So we say f at 7 equals 3 times 7 plus 4. When you're substituting in, use brackets. You'll get questions wrong if you don't use brackets. Okay? You're going to see that today. Anything you get wrong today, good chance you didn't use brackets. So then we do the exact same thing that we did above. Substitute and solve. 21 plus 4. F at 7 equals 25. This is a point that you can graph. Okay? So if we're going to graph that, quickly there's your axes. There's your x and there's your y. Here would be an x value of 7 and a y value of 25, and that would be your point. So when we're saying f at 7 equals 25, what's your x? What is that point? What's your x value? 7, because that's where x belongs. What's your y value? 25. Okay. So 7 is your x value. It's your domain. It is also your independent value. Whereas the 25 part, that's your y value. It's your range. It is your dependent value. Okay. So, let's do a little bit of substituting and solving. We can go real simple, and then we can start getting a little crazy and having some fun, actually. H at 2. So here's your H equation. There's your G equation. H at 2 means you substitute in. H at 2 equals 4 times what? Yeah, 4 times 2. So 8 plus 4, 12. That's your answer. H at 2 equals 12. Do the next one yourself. Go. G at 3. Make sure you use brackets, please. So instead of x squared minus 1, it becomes 3 squared minus 1. 9 minus 1, and the answer is 8. On your sheet, I'm expecting to see a little bit of work, or you will get no homework marks. Okay. All right. Good. Do number 3. Go. Okay, so question number 3. H at -5 equals -16. Any questions? Did you use brackets? Good, because you're going to definitely need that for your homework, especially with negative signs. Okay, does 4 look hard? What does x have to become? It has to become a letter R. Ooh, so hard. Not at all, right? You just change the letter around. So the answer is r squared minus 1. Now we get to have some fun. So instead of x squared minus 1, it becomes bracket x plus 2 squared minus 1. So if you know your perfect squares, you know the answer real quick. If not, you better go and write this out the long way. Multiply out. Okay. X squared plus 2x, that's from the x multiplying. And then take your plus 2 and multiply it. So plus 2x plus 2, sorry, plus 4. And don't forget the minus 1 part. So today's worksheet, you're going to review our algebra skills, our polynomials. Okay, so there's going to be some factoring on there. There's going to be some multiplying and collecting like terms. What's our final answer for number 5? Yep. Plus 4 minus 1? Plus 3. Okay. So all the skills you have, you just have to be careful. Okay? Good. So number 6. What it's saying is find this answer first, G at 3. Who can tell me the answer because they're very observant? Yeah, what does G at 3 equal? Real quick, what is it? What is it? What is it? What is it? Hello, folks. Look here. Yeah. So we already know that one. Otherwise, you'd have to find it. So really what we're saying is, what is H at 8? Okay. So substitute in 4 times 8 plus 4. Show your work. Answer is 36. Okay. Okay, go ahead, do number 7. Okay, so this one is going to be 4 times 3 plus 4, 12 plus 4, 16. Hands up if you got 16. Good. So now number 8 is not the same as number 7, is it? The 3 is in a different location. So we know that h of x equals 4x plus 4 from up above, right? And so what we have to do is multiply it by 3, because we want to know what 3 times h of x is. So we're going to go 3 h of x equals 3 times h of x. So now you got to do your algebra skills and multiply in. So multiply into both. What's the answer? 12x plus 12. Not too hard, is it? Okay. Now question number 9, 3 is in a different location once again. So it's not going to be like question number 7 or 8. So what we're saying here for this one, this is where you guys start freaking out. H of x equals 4x plus 4. But what also does h of x equal? Yep.
When you put the distributive property, you put the 3 over there. Why did you bring the 8 over there?
Are you talking this one right here?
No, when you moved it to the right and you did the distributive property, why did you bring the 8? Like, why didn't you multiply 3 with 4x and 4?
So you're saying, like, why didn't I multiply this one in? Is that what you're saying, Jason?
Yeah.
Well, let's think of it this way, Jason. What the left side is 3 was h of x. What I did essentially is I multiplied both sides by 3 to keep it equal. I'm not going to cross the equal line. Okay, so really I'm multiplying this side and this side by 3. Does that help? Okay, that's probably the best answer I could give you. Okay. Okay, so h of x also equals 3, so I can substitute here. Completely different now. Right? I have to substitute for h of x because that's what it's saying h of x equals. So 3 equals 4x plus 4. This is like saying y equals 3. And I have y equals 4x plus 4. So I would substitute 3 for y. Okay. So you have to be careful how where they're putting the number. So now you can work backwards, solve for x. What's the first thing you want to move? Where do you want to move? The plus 4. So how do you move a plus 4? Minus 4 both sides. Okay, so negative 1 equals 4x. Then what do we do? Divide by 4. So negative 1/4 equals x. That's your answer. Don't give me a decimal. We don't do that. Okay. Good. Okay, same idea now. Looking at question number 10. Question number, do you guys have question number 10 on there? Good, let's do question number 10. So g at x equals x squared minus 1. So where are we going to substitute the 35? G of x, the whole thing. Okay. So we have 35 equals x squared minus 1. So then plus 1, right, to get rid of it, plus 1. 36 equals x squared. Then we have to square root both sides, just like Pythagoras. Square root, square root. So what's the square root of 36? 6. Is that the only answer? Yeah. Could also be a negative because negative 6 squared also equals 36. How come we've never done that before? Why don't we do that for Pythagoras? Jason? Amron? Exactly. You can't have negative measurements. Have you guys ever measured? Is your house negative 2 meters tall? I mean, it goes into the ground. Okay? You're right. You're 6 feet. You're like 6 feet tall. You're not negative 6 feet tall. That'd be kind of weird. Okay, so measurements are always positive. So keep that in mind. But true, and you know what? This is just not a big deal. You're not going to really see that too much, anyways. Okay, that's more grade 11 that they start doing that stuff. Okay. All right, next one. So you're going to see some of these in your textbook. These are a little bit harder, but they're still not different. This is like saying, what's the point? What's your x value? We already did this on the last page. X value is negative 1. What's your y value? Negative 7. Okay, what is it for the other point? 5, positive 9. Not that hard, is it? Just got to know their locations. Okay, so this is your x and that's your y. Good. So the first thing for any equation is to find your slope. Go ahead. So I got negative 16 over negative 6. And we all know that's not a good answer because there's two negative signs and it's not reduced. Positive 8 over positive 3. Okay. So the first thing is to find our slope, then use slope point. What's your slope point equation? Y minus y1 equals mx minus x1. And I want to test you. Let's use the point negative 1, negative 7. Okay. Put those in there in the correct spot now. Let's see if you really remember last unit. So notice I have pluses in there because it would be minus negative 7 minus negative 1, and we don't have double negatives. We have to simplify that. Okay. And that's good enough. The question should say put it into slope point, sorry, put it into slope intercept, or put it into general if they want more. Otherwise, I'm happy like that unless I specify. But you always, 99% of the time, start with slope point. Okay. All right. So that's enough with numbers. Now let's look at the picture. Picture say 1,000 words. What am I saying here? F at negative 4. What's the value? Nope. X. I'm saying x equals negative 4. And here you have to find your y value. So find x equals negative 4 right there. Go up to your graph and go over and tell me what's the y value of that point. Plus 8. Okay, do the next two. Go. Wait, so f at 0. So here's your x value of 0. And on the graph, what's your y value at that point? Positive 2. Okay, f at 4. What is it? So here's 4 for your x. There's your graph. And negative 4 is your y value, or f at 4. Okay. Now we're saying completely different. So now, what value is this? Y equals 4. Find your x value. Is there only one x value? Here's y4. There's a point. And, oh, tricky, tricky. At 4, we have 2 points. So we should actually, for x, have two answers. We have negative 6, comma, negative 1. Okay? There's two x values for that y value of 4. That's a little bit different. Any questions? Okay. Go ahead, answer these questions. Review of what we just did. Go. Okay, does the graph represent a function? Yep, right here, this point is included, but it's not touching the line twice because this is not included. Right? It's an open circle, just like our inequalities. So it's yes, no marks, comma, because each input has one output. Okay. Or what else could you say? And what else could you say? Passes the VLT, or vertical line test. Okay. 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 F at negative 9. Thiessen. Good. Okay. So here's negative 9, and the point is negative 2. Okay. For y. F at 5. Jasmine. 7, correct. Okay, so f at 5 is here, and your y value is 7. Okay, good. F at 1. Anthony.
3 and -2.
Close, but if it's not included, that means it's actually not there. Okay, so the answer would just be -2. Okay, good. Working the other direction now, f at x equals 4. Hamza, 2. So now here's your y value of 4, and at that point on the graph, your x value is simply 2. All right. Any questions? So your homework, you have 2 parts. Turn it over. You have a function notation worksheet. The answers are posted online, and I just want to kind of go over a couple things first with you. So from the website, you're going to go to Math 10 and go to the Answers section. Okay, so right here, you click on it, and click on Function Notation Key. Now, I didn't show work. You guys need to show work. I just want to go over, let me zoom in for you. Okay, so if you look at C, you're going to get a fraction. Nothing wrong with that. Okay? Use brackets when you substitute into that. That's key. Show a bit of work. For your y-intercept, what value is x? Come on. I say x-intercept, you say y equals 0. I say y-intercept, you say, like seriously, you guys need to know that. Make up a flashcard. Okay. Here, substitute in a. Here, multiply by 2. Here, substitute 4x and simplify. Here, substitute that in and then simplify. Okay. For number 5, here, figure out the answer and then figure out the answer and then add them. So you can use brackets here to help you out with that. Put big square brackets around each one. All right. Here, just multiply that out and then collect like terms. So this is just a little bit of the work. You got to do a lot more work than that. Turn over to the back side. So here's more practicing our algebra skills. Show some work. Okay, we're working on polynomials to review that stuff. Number 7. Again, a little bit more algebra. This is again a little more intense. D, you're not expected to know D. That's way above us. Okay, it's the honors, but some people are ready for it, so I just want to show you what you can do. 8, this is all factoring. You can just cross off the function and just factor it. Just factor it. Don't worry about that g of x or j of x or anything like that. So take out a GCF. Take out a GCF and then trinomial. Take out a GCF, difference of squares. Simple trinomial, sum product. GCF and then sum product. Here, sum product, actually box method, this one. E is box method, F is box method. P, difference of sum product, and then difference of squares. H, GCF, and then box method. So we're just reviewing our last unit from before, polynomials and factoring. Okay? Great stuff, good time to do it. There is some textbook work as well, so do the textbook as well. The textbook work is some substituting, solving, and looking at graphs. Yes, you need to know the length of your humerus. This is your humerus right here. If you don't want to measure it, estimate it. We did do a unit on measurement where we had talked about references and estimating lengths. You should be able to estimate the length of your humerus in centimeters. It'll probably be around 20 to 30. Any questions? Oh yeah, get at it. Go. You got 40 minutes to get your homework done.